determine whether these devices are useful or not, we must first determine the output power characteristics as well as the reliability. Therefore, our first goal for the project is to develop a system where we can characterize these cantilevers and confirm the results found in the test-based lab upstairs, as well as to characterize the cantilevers that have yet to be tested. Once we have those baseline results, we can then proceed to do reliability testing, where we would find out if the cantilevers still perform the same way under long-term vibrations. And our final goal for the project is to use console multiphysics to explore ways to reduce the resonant frequencies of these cantilevers. Because currently, the micro cantilevers are most efficient around 3.6 kilohertz, which is much higher than the vibrations that are found in the natural environment. So it's harder to find applications for that. So we have been working to achieve our goals all semester, and Chris and Justin have been the ones working towards the characterization goal. And we have run into quite a few problems with that, mostly related to the accelerometer and to interference. And all of us worked together to resolve those problems, but we are still unable to get results that quite match the values found in the test-based lab. Without those baseline results, we were unable to proceed with reliability testing. However, Carson and I did convert the speaker into a low-cost shaker for future reliability testing. And finally, Alex Wu worked on the console multiphysics, and he was able to model the current cantilevers, and he found results that did match the ones found experimentally by Erica Fuentes, the PhD student who made these cantilevers. And to reduce the resonant frequency, he added a proof mass to the end of a current structure, which simulated a dramatic reduction in resonant frequencies and an increase in displacement for acceleration. So after all of this, we have determined that for the next semester, we really need to finish troubleshooting the characterization shaker, and I guess we can go ahead and start on the reliability testing using those that Erica has already measured at the values. Thank you. Do you have any questions?
How exactly are you doing the reliability test?
What?
How exactly are you doing the reliability test?
We're just going to shake the cantilever long period of time, periodically stop and measure to see if we're still getting the same output or if it's reducing. We have actually been looking into Weeble analysis, which is different ways to test the reliability, such as I think like there's 10% left still working after this time period.
So how are you picking what frequency you vibrate at?
Oh, we're going to vibrate at the resonant frequencies that we measured.
What kind of frequency sweep is part of the characterization, determining what the maximum output happens at a certain frequency. That's what we're using as the resonant frequency.
And that would be used at in these applications?
That's ideally we're gonna, with the proof mass and everything else, we're gonna lower it down and then either find applications that use that frequency or try to vary it. If you have modifications to get it to a frequency that's useful.
I'd also like to add that we have considered doing reliability testing at other frequencies and possibly taking accelerometers and recording motion and replaying those on with the shaker to see how the devices behavior.
When you said in characterization that you confirmed the inaccuracy of the accelerometer, what do you mean by that? Was it outside of its specs or
Yes.
how far out?
It says that it's supposed to work at 10 millivolts per G, and we actually compared it to the one in the test-based lab, which was working at 10 millivolts per G, but it looked like they were running at 3 Gs and theirs were at 30, and ours was reading 52 millivolts. And like
Compared to the spec sheet, how far out was it?
Well, that's 50 millivolts, so that's like 40% off. I mean, a lot. It was so yeah, it fluctuated. It didn't seem to be linear.
And was this just one test element or was it a lot across the board? Was it a single accelerometer?
Yeah, it's just with one accelerometer. We only have one
Oh, you
accelerometer.
only have one.
You have no way of knowing if it's just in that.
Well, yeah.
At this point.
That's been kind of our issue. We're having trouble testing it because we have limited access to the Texas lab.
Was that affected the spec under which the voltage was defined? And did you measure the same spec?
It's connected separately for all of our tests.
We haven't baked it.
been too concerned about temperature and the results, not yet. Once we get a characterization running, we have to consider recording temperatures and stuff, at least having that data. So to accurately